Let's solve the following problem, which asks us to investigate whether the following series converges or diverges by comparing it to a simpler series. The infinite series that we are given is the sum of k squared divided by k to the power of 4 plus 2k plus 1, with k going from 1 to infinity. So these are the numbers that we have to add up and see if it goes to some finite number or diverges. So let me just first of all point out that these are all positive numbers that we are adding up. And also, whenever someone asks you to look at an infinite series such as this and decide whether it converges or diverges, and it's too complicated, it is a good idea to compare this general term, take this general term and look at the terms, look at the various terms in it for large k, and try to identify the dominating terms for large k. So for large k, if k is, I don't know, 100,000 or a million, the terms that will dominate these numbers are upstairs is the term that we have, k squared, but in the denominator it's k to the power 4. It's going much more rapidly than 2k plus 1. So for large k, it is roughly equal to k squared over k to the power 4. Okay? For large k, we can forget about these terms that are not dominant. So this k squared over k to the power 4 is 1 over k squared. And if we would have that series, now we know from the lectures that the sum of 1 over k squared is a convergent series. So we expect convergence. Okay? Because for large k, this series roughly behaves as a series, the sum of 1 over k squared, with k going from 1 to infinity, that we know to be convergent. Okay? All we have to do now is what we were told to do, is to compare this series to a simpler one and see if we can do that. Well, let's see. So we have k squared divided by k to the power 4 plus 2k plus 1. Now, can I maybe give an upper bound, an estimate, that would be greater than this expression and would somehow smuggle this 1 over k squared in? Well, we can certainly do that, because if we leave out this 2k plus 1 term, this is a positive. So this is a positive number. So this is greater than 0. If we leave it out, we are dividing by a smaller number, getting a greater result. So this is definitely true, that k squared divided by k to the power 4 is greater than k squared divided by k to the power 4 plus 2k plus 1. But this is 1 over k squared. So by the comparison test, if you would like to put it this way, by comparing it to a already known series, a series that we already know to be convergent, we can say the following. This infinite series, its sum, it's going to be less than or equal to, doesn't really matter at this point, than the sum of 1 over k squared, which is a finite number. This is our way of saying that this is a convergent series. So it is. The original series is convergent. Okay,